Let's talk about phases and phase changes within water. So our delta H of vaporization for water, so the energy that it takes to go from the liquid phase into the gas phase, is 40.7 kilojoules per mole. But our delta H of fusion, so going from a liquid to a solid, is only 6.02 kilojoules per mole. So why don't you think for a minute about why that delta H of vaporization is so much greater than the delta H of fusion. If you were thinking about breaking intermolecular forces, you're correct. So to go from the liquid phase to the gas phase, you have to break all of those hydrogen bonds holding the liquid together. Whereas when you go from the solid phase to the liquid phase, you're breaking some hydrogen bonds, but not nearly as many as you are going to the gas phase. So this diagram is showing the heat needed for each phase of heating up water. So if you want to warm up ice, it takes 0.941 kilojoules per mole of ice that you're melting. Then at the melting point, you have to melt all of the ice before you can start warming it up again. And so that takes 6.02 kilojoules per mole. Then when you warm up water from the melting point up to the boiling point, it takes 7.52 kilojoules per mole of water. And then boiling water, you can see, takes the most amount of heat because you have to break all of those hydrogen bonds. So that's going to take 40.7 kilojoules per mole. And then to warm steam up, there's 0.904 kilojoules per mole of energy required. So back to our phases of water, we talked about vaporization and condensation and how they're opposites of each other. So the delta H of vaporization is 40.7. The delta H of condensation is going to be the equal and opposite, so negative 40.7 kilojoules per mole. Then our delta H of fusion, 6.02, and then to go the opposite way is going to be negative 6.02. Then if you notice, you can also go from the solid to the gas phase. Going from solid to gas is called sublimation. And the delta H of sublimation, remember delta H is a state function, and so it doesn't matter if you go through the liquid phase or if you just go straight, your delta H is going to be the same. So our delta H of sublimation is simply the delta H of fusion plus the delta H of vaporization, getting us 46.7 kilojoules per mole. And then the opposite of that is called deposition. So let's do a calculation here. How much energy does it take to transform 18 grams of ice, which is 1 mole, at negative 25 degrees Celsius to steam at 125 degrees Celsius? So we're going to have to use these numbers here on this slide. And I'm going to, here we go. So the first thing we have to do is heat up our ice. And from this slide here, we see that it takes, I'm going to do everything in moles because that's the number 1 instead of 18. So that takes 37.6 joules per mole times Kelvin. Oops, wrong way. So 37.6 joules per mole times Kelvin. And we're going from negative 25 to 0. So we're going to take our negative 37.6 times 1 mole times 25 Kelvin. Gets us 940 joules, or 0.940 kilojoules. Then we have to melt our ice. Melt ice. There we go. And that takes 6.02 kilojoules per mole. Times 1 mole gets us 6.02 kilojoules for melting. Then we have to heat our liquid from 0 to 100 degrees Celsius, and that's going to take 75.2 joules per mole times Kelvin. So that times our 1 mole times 100 Kelvin is going to get us 7.525 times 10 to the third joules, which is 7.525 kilojoules. Then we have to boil our liquid, which takes 40.7 kilojoules per mole. Gets me 40.7 kilojoules. And then we have to heat our steam from 100 to 125, I believe the question is. Yep, so to steam at 125. And that takes 33.2 joules per mole times Kelvin. 33.2 joules per mole times Kelvin times 1 mole times 25 degrees Kelvin, so 125 minus 100, and that will get me 831 joules, or 0.831 kilojoules. And then I can just add up all of my kilojoule numbers to get my total of 56.0 kilojoules of energy to heat water from -25 up to 125, going through 2 phase changes.